In this video, let us continue to solve more problems based on complex numbers. Alright, here we are. We've got a question which says, find the modulus and argument of each of the following complex numbers. Well, the one of the complex numbers that we have is 1 plus I times square root of 3. So now let us find the modulus of this complex number. It's given by, let's take this to be equal to z equals 1 plus I times square root of 3, right? So the modulus of z is given by this mod of z, which is equal to square root of a square plus b square, right? A is 1 in this case and b is square root of 3. So we've got square root of 1 square plus square root of 3 the whole square, which is nothing but square root of 1 plus 3, which is equal to square root of 4, which is equal to 2. So therefore the modulus of this particular complex number, that is 1 plus I times square root of 3, is 2. And coming to the argument part of it, as we discussed in the previous video, the first step to find the argument of a complex number is to find something called as alpha, which is given by tan inverse of the imaginary part of the complex number divided by the real part of the complex number, right? So we have tan inverse of the imaginary part of the complex number is square root of 3 divided by the real part of the complex number is 1. So it's just tan inverse of root 3, right? So alpha equals tan inverse of root 3, which is equal to pi by 3, because tan of pi by 3 gives you root 3. That's exactly what we have to find here. So alpha is given by pi by 3, or in other words 60 degrees, but we have to write it in this form. So the finding the argument does not end here. We also have to look at the imaginary parts of the complex number and the real parts of the complex number. So in this particular case, the imaginary part of the complex number is greater than 0, and so is the real part of the complex number. It is also greater than 0. So therefore, the argument of the given complex number, or the argument of z, in this case it is 1 plus I root 3. Now, argument of the complex number when the imaginary part and the real part are both greater than 0 is equal to alpha. So in this case, alpha is given by pi by 3. So the argument of 1 plus I times square root of 3 is nothing but pi by 3. So this is how we find the modulus and the argument of a complex number. All right. So that ends this problem. Let's quickly solve another problem before we conclude this video. Alright, so here we are. The question remains the same. Find the modulus and the argument of each of the given complex numbers, each of the given following complex numbers. So this is one of the complex numbers that is given, 1 plus I divided by 1 minus I. But we first have to write it in the form of a plus ib and then proceed from there. So what we have to do is we need to multiply both the numerator and the denominator by the conjugate of the denominator, which is nothing but 1 plus I. So therefore it will be 1 plus I divided by 1 minus I multiplied by 1 plus I divided by 1 plus I. So 1 plus I times 1 plus I is nothing but 1 plus I the whole square, which will be 1 plus I square plus 2I. And the denominator is of the form a plus b times a minus b, which will be a square minus b square. So it will be 1 minus I square. So we know that I square is negative 1. So it will be 1 minus 1 plus 2I divided by I square is a minus 1. So minus 1 into minus is going to be plus 1. So 1 plus 1 is going to be 2. 1 and negative 1 gets cancelled. So all we are left is with 2I divided by 2. So it will be just equal to I. So therefore, we have 1 plus I divided by 1 minus I is equal to I. Or rather, we cannot just write it as I. We need to write it in the form of a plus ib. So it will be 0 plus 1I. Right? So this is the complex number that we've got, of which we have to find the modulus and the argument. So the modulus, let's take this complex number to be equal to z equal to 0 plus 1I. So the mod of z will be equal to square root of a square plus b square, which is nothing but square root of 0 square plus 1 square. So therefore, since 0 square is 0 and 0 plus 1 square is also 1, so square root of 1 is 1. So the modulus of z is given by 1. So one part of the problem is finished. The modulus of 1 plus I divided by 1 minus I is given by 1. Alright, now we have to find the argument of the given complex number, which is 0 plus 1I. So for that, we first have to find alpha, right? So alpha is given by tan inverse of the imaginary part of the complex number divided by the real part of the complex number. And the imaginary part of the complex number is 1 and the real part is 0. So 1 divided by 0 is infinity. So alpha equals tan inverse of infinity. So tan of what gives you infinity? So tan of pi by 2 gives you infinity, right? So therefore, alpha equals pi by 2. We've still not come to the end of the problem. It's only half done because alpha is found to be infinity. Now what we have to do is we need to see whether the imaginary part and the real part of the complex numbers are greater than 0, less than 0, whatever that is. Now in this case, it doesn't fall under one of the conditions that we've discussed. In this case, imaginary part of the complex number is greater than 0, but the real part of the complex number is equal to 0, which we haven't discussed. So in that case, what it means is, now since the real part of the complex number is exactly equal to 0, that means the complex number z lies on the y-axis, which makes the argument of the complex number to be equal to alpha. So therefore, the argument of 0 plus 1i will be equal to pi by 2. So that ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on the complex numbers.